Hi everybody. Today my topics is linear programming. The term linear, it means that all equations and inequations involved are linear. Programming, this term means planning to maximize profit, minimize loss, minimize cost, minimize the required time, and as well maintain minimum use of resources. Basically, it is an optimization problem. Let's move ahead to find in details of it. Mathematical model of linear programming, it consists of three parts: decision variables, constraints, objective function. As I told, linear programming problems, it deals with optimization. That's why we can say it is the process of finding optimum solution for an objective function. How? By changing decision variables with respect to constraints. Very important points. Decision variable. We have to identify decision variables. How? Let's see the example of linear programming problems. This is the problem. Here it says a small company, they want to purchase a number of chairs and tables, and they intend to invest only 10,000, and they have limitation about space. It is for space, it is for at most 80 items, and each chair and table cost is $100 and $200 respectively, and they can sell a chair at a profit of $9 and table at a profit of $17. So if they can sell whatever they buys, so on these conditions, how should they invest their money in order to maximize their profit? So in this problem, first we have to formulate the LPP, and then we'll solve it graphically. So this point, decision variables, we have to identify this. So what is, where is this? It is chair and table. And it says express them as X and Y. That's why I put number of chair purchased as X, number of table purchased as Y. Now for the constraints. We have to identify constraint in the linear programming problems. How to do that? Suppose here has a space for at most 80 items. So this is the limitation. So X plus Y less than equal to 80. This is first constraint. What about the second constraint? Cost is 100 and 200 respectively. As well, they want to invest only 10,000. So constraint is at most investment 10,000. So this is the limitation. So 100x plus 200y less than 10,000. Dividing both sides by 10, we can get the equation as this: 10x plus 20y less than equal to 100. So this is constraint number 2. Now we are trying to find constraint number 3. Here it says number of chairs and tables are non-negative and x greater than equal to 0 and y greater than equal to 0. Non-negativity constraints means that we have to work in the first quadrant of the graph. When we plot the graph, we have to work on the first quadrant. And here we have two constraints and one pair of non-negativity constraint. And also we have seen here these two, already I marked here, we used it here. Now objective functions. Identify objective function. Say it is z. We have to optimize this. I mean, it can be maximized, it can be minimized. And we can express this z in terms of x and y. But how to get the equations? Look at the problem. Profit of $9 for the chairs and profit of $17 for the table. So we have to use these two to create this. So to maximize profit, our equation will be z equal to 9x plus 17y. This is objective function equations. Now we will make a table of informations of variables. Already we have seen lot of informations in the LPP, I mean linear programming problems. So here we brought all those informations like chair cost, table cost, total investment money, profit for chair and table, as well as space limitation 80. Now we will create the mathematical formulations. What are those? Like to maximize this. Already we have seen this equation in the previous slide, but we are bringing all those equations in one place. So this zone of equations will be called as mathematical formulations. So I am putting subject to constraints. We have seen these three equations in the previous slide. I am writing it here again. X plus y less than equal to 80, 10x plus 20y less than equal to 100, and x greater than equal to 0, y greater than equal to 0. So this is the mathematical formulation. We have to create this before making the graph. Now we are moving towards graphical solutions. So we brought here three constraints. What we had, this first one, I am converting this inequality to a linear equation as this one, x plus y equal to 80. Now we need to plot each constraint, this constraint as well all this constraint equation we need to plot on the graph. To do this, we have to find 2 points for this equation as well for these equations. Normally, 2 easiest points are the intersection between these linear equations and these 2 axes. The easiest points. How to do that? If we put y equal to 0, we get x equal to 80. Look at this. If we put x equal to 0, y equal to 80. I am bringing the graph what we are doing at the end, but I am bringing here as a sample to compare with this one. Let's see that. So this is the graph we will plot. So here, if you look at this red one, we put these 2 points. 80, 0, these points, we put it here, and 0, 80, it is here. Now we draw this line between these 2 points. So we got the line in the graph. Now we'll go for the second equations. (10x plus 20y equal to 1000). Same way, easiest way, taking this y value 0, x will be 100, and x value 0, y will be 50. So we have points 100, 0 and 0, 50. So we draw a line because 0, 50 this point and 100, 0 this point. So we draw this line between these 2 points. Now here we have this graph with the equations. But here I have written corner point solution method. It is based on fundamental extreme points theorem. Very important points. It is based on fundamental extreme point theorem. Because we have to identify the corner points on this feasible solution, feasible region. Already I wrote here to locate feasible region. This is the feasible region. Because in this feasible region, we can identify, we can get the feasible solution from this feasible region. These feasible regions, we'll try to find the solution, optimum solution. That is called optimum solution. Because if we look at the graph, you can see there is 80, there is this point, and there is also this point. But I want to tell something about this point, how we are getting this. Say this is 0, 0 as the specifying point, because if I put this 0, here 0, so it is total result is 0. Of course it is less than 1000. So it satisfies. So we can say this 0, 0 belongs to this feasible region. So this is our feasible region. And to be sure with, this is bounded region, bounded feasible region. It is very important points. because there are two types of region, feasible region. One is bounded, another is unbounded, but this one, it is bounded region. And so with these points, and there is one point already here, there is another point already here, so we have to get these points. It is intersection of these two. So let's see how to get that. So I put here this equation, x plus y, this red line equal to 80. So y equal to 80 minus x. Putting this y value in this equation, second one, this blue line, you will find x equal to 60, y equal to 20. So 60 and 20, it is the intersection of this red line and this blue line. So how many points we got? So there are 4 corner points, 1, 2, 3 and 4. And mathematical theory is that optimum solution must lie at one of the corner points of x, or these extreme points. One of these corner points, optimum solution we shall find. So we have to look at the profit for every corners, because already I told this is bounded and optimum solution is here in these points, either here or here or here or here. Optimum solution, this is the mathematical theory. It lies at one of the corner points or extreme points. So what we can write as, and also I want to mention, as this was less than 80, this was less than 1000, it means our feasible region will be towards the origin. It is very important points. Both are less than or equal to. So our feasible region is towards origin, this O. Now we will write our this region, we can write it as O, P, T, S. That's why I put here points P, T, S, O are the corner points. So we have to use these points to find the profit. So we have this equation. Now we have to find this value for objective function, value for z. So what we will do? We will use this point in this equation, it comes 720. If we use this t 6020, we get 880. If we use 050, we get 850, because we have these 3 points, but I did not put here the value for the 0 because it will give 0, so I don't need that. Only these 3 points I use to compare which one gives maximum profit. So here it shows 880, it is the maximum profit from this point, intersection of these two lines, red line and blue line. This intersection gives the maximum profit. So what it says, this 60 is the chairs, 20 is the table. So easily we can write profit will be maximum when 60 chairs and 20 tables are purchased and sold. That's all for today. Thanks for watching.